Live Recovery, all right? Instead, it's a peek behind the curtain of how one specific customer has actually adopted the technology and is using it for their specific IT and business DR solution, right?
Hello, everyone. My name is Brian Donofrio. I'm a pre-sales solutions engineer on the VMware team at SHI. And if you have not heard of SHI, we are a large value-added reseller based in the United States. We do have a global presence, though, and here's a quick peek at our company profile just so you can see some rough numbers, right? We have been around for 30 plus years, and really our main goal is to assist customers with the entire technology lifecycle, right? Whether that's software, hardware, IT services, what have you, right? So that you can see our kind of methodology, if you will, is adopt, address, acquire, and what that entails is helping customers strategize about their technology needs, what's on the roadmap, where do they want to be in 1, 2, 3 years, right? We'll ultimately help them evaluate different solutions, procure that solution, get it deployed, and then make sure they're utilizing that solution to the best of their ability.
All right, so just to set the stage, make sure we're all reading from the same sheet of music, as they say, right? It's the one pager, just to make sure everyone understands what VMware Live Recovery is, all right? So VMware Live Recovery is really just a repackaging of some legacy VMware DR technologies, all right? Formerly VMware Cloud Disaster Recovery and formerly Site Recovery Manager, been rebranded and repackaged inside the VMware Live Recovery solution, all right? So when you think about VMware Live Cyber Recovery, again, formerly VCDR, that solution really focuses on on-prem to cloud disaster recovery and ransomware recovery, as well as cloud to cloud. And then Site Recovery Manager is that focus on on-prem to on-prem DR, as well as disaster avoidance, right? So that's kind of the lanes that we're going to be kind of staying in today.
All right, with that being said, let's dive right into this customer scenario. So this customer is a US-based multi-site organization, and really they approached SHI and Broadcom with the one big ask of they wanted to revamp their disaster recovery solution, right? So some of the requirements that they laid out for us in our initial conversations was a desire to move away from their current rigid architecture that was not able to scale or adapt with the changes in their industry, right? They do have a significant investment and reliance on their IT infrastructure to support their business needs. They are one of the largest companies in their field, so staying on that cutting edge is very important to them. That being said, one of their requirements was that the solution needed to be agile. It needed to scale with their remote and corporate workforce. And then they also wanted to look at cloud first initiative, right? They wanted to look at cloud as opposed to their existing on-prem DR solution and avoid vendor lock-in. So some of the challenges we uncovered when, starting the conversation with this specific customer, and again, this is not anything new in the industry, right? They had a small IT team responsible for managing quite a few workloads, right? They had almost 1,000 VMs across multiple physical sites. Aging hardware in their DR colo site is kind of what was driving this project, right? And they just had a lack of operational bandwidth with their current IT staff to do a full disaster recovery refresh. They do have a lot of high operational overhead with their day 2 operations, like I'm sure most of us are familiar with, right? Updates, patches, etc. Just maintaining that production hardware so they can keep their business running. And then in place today, they had multiple disconnected disaster recovery solutions, right? Kind of another common scenario we hear is you use multiple different solutions to kind of piecemeal together one cohesive disaster recovery solution. But in this case, they were looking for something that was standardized, something that was one solution that could meet all of their needs if possible.
All right, so jumping straight into the discovery phase. And as I'm sure most of you can relate, when you really dive into the discovery, when you're taking on any kind of large-scale project, you tend to uncover a lot more complexity than what you bargained for, right? And this was no exception with this customer, right? As we peeled back the layers of the onion, so we kind of dug a deeper hole for ourselves and uncovered some really interesting requirements, even beyond the initial scoping conversation, that really did affect the trajectory of the design and the implementation. All right. So this is by no means an exhaustive list of what we really discovered, in kind of kicking things off with the customer. But these are kind of the key points that I chose to highlight because they really did, again, affect how the solution came about and the considerations that went into it. So first and foremost, we discovered that the customer had 3 primary physical on-premise locations, right? These are geographically dispersed locations, different areas of the country. and a number of remote office locations that were connected directly into one or potentially more of those 3 physical locations, right? 3 physical locations, very well connected, leveraging high-speed, low-latency connectivity via the internet, so a lot of bandwidth between those physical sites. Customer was very, very adamant that with this DR solution, absolutely had to avoid re-IPing of workloads in the event of failing them over into the DR location, right? Again, Brian mentioned very small IT team, all right? Having to re-IP potentially thousands of workloads is just more overhead than this team was willing to take on, especially during a DR event when everyone is running around panicking as you kind of do, right? Low RPO and RTO, right? I think there's no one out there that's implementing a DR solution that doesn't want the lowest possible RPO and RTO out there, right? From a recovery point objective, right? This customer wanted, the least amount of data loss, as any customer would want. Initially, this was a little bit of a moving target, right? Because the customer said, yeah, we want the lowest possible RPO, but we all know that, there's a number of things that influence RPO, right? What's the rate of data change? How often are we moving that data, and how big is the pipe we're moving it over, right? And these 3 things really do influence what our RPO actually ends up being at the end of the day, right? You're moving the data from for 1 VM, not a big deal. 1,000 VMs, all right, now we have to start thinking a little bit outside the box. RTO actually also played a very important role into what the architecture that the customer ended up going with from the cloud DR side, right? And Brian will talk a little bit more about that in a minute. Workload categorization was a huge effort that the customer undertook. In fact, we actually gave the customer homework, and we said, look, you guys have to go and you have to identify and tier or categorize all of these workloads that you have, right? We need to know tier 0 business critical applications. We need to know which apps those are, tier 1, tier 2, tier 3. But then we also said, look, we need you to identify outliers, right? And outliers are really those applications that the customer has that don't lend well to being snapshotted and recovered in another location for whatever reason that may be. And applications that fell into this category, very, very large database servers on the customer side, right? Just they had to be their own little special animal, right? Customers very, very cost conscious, right? And I don't say this because they were trying to cut corners from a spend standpoint, but they wanted to maximize their investment that they were paying for, right? So they said, look, we know we're going to purchase some kind of cloud environment. We want to absolutely run production workloads in that cloud environment, in addition to having it available for our DR workloads as and when we need it. They wanted a solution that would scale beyond just your traditional, meteorite strike taking out a building or fire burning down the data center or something like that. Ransomware is probably the biggest threat on the landscape right now, and who knows what it'll be next year, right? But the customer needed a solution that could address all of these potential issues. They kind of threw a curveball at us here, and they said, look, we want to be able to recover as well from a partial site failure. And what they meant by that was individual application failures. In one of those 3 primary locations, if an application fails here, I want to be able to just DR it over to my DR site and run it there without impacting my prod environment. And then finally, audit requirements. This customer is bound by certain regulatory requirements. So having a well-defined audit trail of what their DR solution was, when last it was tested, how often it was tested, and did it actually work? This is all very, very important to the customer. All right. So one of the things that SHI does phenomenally well, and I've been working with these guys for many years now with a lot of these customer initiatives, is during the whole design phase, during the deployment phase, they provide these really detailed architectural diagrams to the customer. Now, a lot of detail has been removed from this diagram from a privacy standpoint for the customer, but this is just an example of what we provide to the customer, or I should say what SHI provides to the customer during the course of this engagement. So what we're depicting here is the 3 physical on-prem locations of the customer, right? Site A, Site B, Site C, right? At each one of these locations, the customer had elected to extend a number of networks between these physical on-prem sites, right? So they were using a third-party tool to extend networks between locations, right? So just the way it's depicted, site A, yellow networks, extended to site B and C, site B networks, purple networks to A and C, and site C, green networks to B and A, right? Site C predominantly contained database servers, so this are those outlier applications, right? Those really big database servers, some regular VM workloads also located in site C, and then the majority of the customers' workloads spread between A and B, somewhere in the region of about 1,000 virtual machines, right? We mentioned that some prod workloads were going to be moved to the cloud environment, and then network infrastructure services available at all three of these locations, right? So AD, DNS, DHCP, your regular stuff available at all three of those locations. All right, so this lays the foundation of what we figured out the customer had.
All right, so after understanding the customer's requirements, their challenges, and then ultimately what we're dealing with from their on-prem architecture today, we start to introduce the VLCR, right, the VMware Live Recovery, and VMware Cloud on AWS components. So this kind of steady state diagram, as we call it, marries up those two architectures, right? Their on-prem configuration and what it looks like when we introduce these VMware Cloud solutions. So as you can see here, this is meant to be the status quo, right? The day-to-day, okay, nothing's going on. This is what the architecture looks like. One of the requirements here, this customer did opt for a pilot light environment or a warm standby site. So that VMware Cloud site is actually always up and running, right? That was able to then meet the requirements of low RTO, right? Because as their VMs fail over, they can just instantly power on, and however long that takes is what their RTO will be, right? Because that environment is live. Those servers are always running. All the networks are pre-configured, as you can see there. And another thing that they wanted to take into account was their SQL VMs at Site C, right? So while those didn't lend to be they don't work nicely with the VLCR solution. So what we kind of did with that is they opted to have a SQL cluster. If you can see that small, the third one in the VMware Cloud environment, to actually replicate their SQL servers using native tool always on, right? So even though it may not have been a part of the VLCR solution, it's still part of their overall disaster recovery plan, and we can't just forget about them. One other thing, as you can see here, those networks that we highlighted in just the slide before that are color-coded, they wanted to extend those over to the cloud as well, right? And there were some challenges with that because we were leveraging the HCX tool that comes included with these solutions to stretch those networks. There's the challenges we faced is avoiding a routing loop, right? So you can imagine if you're stretching a network from more than one site and you kind of create a closed loop scenario, that's not good. All the networking people would probably have a really bad day. So we really sat down with the customer for some time to discuss what that kind of HCX architecture would look like and really help them plan where to stretch the networks, which ones to stretch from which site, et cetera, so that they avoided any of those kind of caveats and routing loops that could cause issues. This customer did also opt to not use mobility optimized networking, which is a feature within HCX to reduce hairpinning back to the on-prem default gateway and infrastructure services. In this case, they did want all ingress and egress to flow back to on-prem during normal steady state operations, right? Lastly, this customer did, just as a to kind of further protect themselves, is they did also run replicas of their infrastructure services, so DNS, AD up in the cloud, so that they could best prepare themselves should something happen, right? A scenario that takes out maybe multiple sites, which we'll get into in a second here, and those AD DNS services are not available on-prem. Additionally, where they did want to, utilizing BGP, advertise that default route back to on-prem just so they can utilize their tools that they're familiar with in the on-prem infrastructure.
All right, so the first scenario that we designed for, and again, this is probably the most common one that the customer would more than likely face, right, is that of a single on-prem site failure, right? And, the example we're showing here really could be applied, the methodology could really be applied to any one of the sites that would potentially fail on-prem. We just chose site B because we don't like site B. But in this scenario, right, essentially what's going to happen, right, is everything going into site B is not going to be able to go into site B anymore, and coming out of site B, those network extensions are just not going to be there, right? So from a recovery standpoint, the customer had a couple decisions to make. And the first decision really was, is this an actual DR event, right? So none of our solutions, or I should say none of VMware by Broadcom solutions from a DR standpoint, make that determination for the customer. All right, customer has to make that decision, say, all right, this is a DR event, I'm gonna push the button now, okay? So that would be step one, right? Step two is, obviously they would select the recovery plan within VCDR. Freudian slip, you guys didn't catch that, right? In live cyber recovery, that obviously marries up to the site that it failed, and they would then execute that recovery plan. Now, within the recovery plan, within that runbook, we actually built in a number of pauses or brief stoppages in the recovery plan to allow the customer to do some manual intervention. And these are things that couldn't be built into the automation of the solution at the time. And the first thing would be, got to fix the network, right? Because with this side being down and the network extension going into the cloud side and the default gateway still sitting over here, well, this extended network on the cloud side doesn't have a gateway anymore and there's no traffic going anywhere, right? So that would be the first thing the customer needed to fix. Now, HCX is obviously what we used to extend the networks from on-prem into the cloud. But the customer had their own on-prem solution that they were using already for on-prem network extension. So they'd have to first decide which site they would want to re-extend the networks from the failed site from, right? And this is a lot of thought went into this because there's a very, very complex architecture. But in this example, we're showing that the customer decided to re-extend the networks from site B from site A, right? So the purple networks that were originally being extended from site B would now be extended from site A. Customers leveraging BGP throughout their environment, so route propagation, not a big deal. And as soon as networks are extended and advertised from another site, BGP takes care of all of that. HCX, on the other hand, we had to force disconnect that network extension with HCX on the cloud side, right? Now that segment still exists in the cloud. Even though we've disconnected it, it's now just an isolated segment in the cloud. So we'd re-extend those networks from the HCX manager on site A back into the cloud. And HCX is smart enough to understand that, hey, this is actually the same network that is being re-extended back into me again. I'm just going to connect these guys back up again. So now, network extension, purple networks re-extended into the cloud. The gateway now resides in site A as opposed to site B where it was originally. All right, a lot of intelligence there. A lot of thought went into that one as well. All right. So obviously, infrastructure services, obviously continuing through the recovery plan, moving past that, and then workloads would be brought up in the order in which it was defined within the runbook. Workloads that had a higher priority or perhaps had dependencies from other workloads on those would be brought up first. You guys kind of understand how that works, right? So a lot of intelligence and flexibility built into live cyber recovery runbook. The customer would actually still continue to use infrastructure services on-prem, right? Even though they had those services located in the cloud, again, the default gateway for all these networks is still on-prem. So the traffic's still going back on-prem. Customer decided, look, for now, we're just going to use the services we have here. Not a big deal, all right? Because of the layer 2 extension, customers didn't need to re-IP any of their workloads, right? Those workloads would essentially be brought up on the cloud side, on the same network that they were on-prem, same MAC address, same everything, just a different physical location, but the same network, all right? So no re-IPing required for any of those workloads. As for the users connecting into the failed site, they would just connect to one of the other sites out there, and again, BGP, network propagation, etc. They'd be routed, via whatever method necessary to get to the workloads that were now running on the cloud side. All right. So, like any good DR solution should provide, right? Live cyber recovery gives the customer a fairly simple way to fail back those workloads back to on-prem once that disaster had kind of moved on, or the data center was rebuilt, or whatever it may be. Simply a one-button push turns that recovery plan 180 degrees around, allows replication back to on-prem using Delta syncs if data is already seeded on site B, right? And then just allowing the customer to schedule at a time that's convenient for them when to bring those workloads back to the original location.
All right, so the next scenario that they wanted to plan for was a multiple on-prem site failure, right? So it can be any combination of these three sites. We just chose A and B in this case. As you can see, a very similar result to what we just saw on the previous slide. However, there's obviously some caveats we need to talk about with this scenario, specifically around the prioritization, right? So VLCR can only run one disaster recovery plan at a time, right? So, and then it's sequential, right? So once that one finishes, the second one will kick off. But here the customer needed to make a determination, right? Depending on the outage, depending on the disaster scenario they're dealing with, which site or which recovery plan they wanted to run first, right? So that goes back to what we talked about at the beginning, where we had them categorize their workload so they could determine that priority. And then with the manual intervention to determine how bad this disaster was, could then run that respective plan to bring up those highest priority applications first. Think business critical, right? Those kind of tier 0 workloads. Just like we saw in the last scenario, those layer 2 extensions no longer available, right? Everything's gray. But as you can see in this diagram that we're depicting, you can re-extend the networks, all those 2 site networks back from site C out to HCX, right? Paul just talked about how there's the intelligence built in that HCX is smart enough to pick that up. However, again, given the scenario the customer was presented with, we also let them know that there is an option to not re-extend the networks, right? And what will end up happening is they would force disconnect those layer 2 extensions from the impacted sites. And essentially, throughout that process, there's a way to swing the default gateway over to the cloud side and utilize the default tier 1 NSX routers over there, right? That's built into the VMware Cloud solution. So again, we just wanted the customer to be aware of their options, that while this example is depicting re-extending, if they opted not to, depending on the level of effort to re-extend, how many networks were down, et cetera, they could just swing those gateways over to the cloud. All those AD, DNS services we talked about, that's why they were keeping copies up there. They really wanted to cover themselves from all possible scenarios.
All right, so the third scenario is probably the least likely to happen, right? Yeah, I think kind of like apocalyptic Mad Max kind of scenario, right? Everything is down, everything's gone. Given the nature of the way this customer was laid out, there's geographically dispersed physical on-prem locations. If they ever had to deal with this kind of scenario, my opinion is there'd probably be bigger things to worry about than get your company's DR plan going, right? But that's me, right? So although this is by far the most impactful scenario that we designed for, arguably, right, it's actually the least complicated, all right? And the reason why is we don't have to deal with all of these network extensions all over the place and making sure that we unextend and re-extend and don't create a layer 2 loop all over the place, right? There's nothing left on-prem, all right? We don't know where it is. We don't know why. So basically, at this point, we're forced disconnecting HCX networks, okay? And we're swinging the default gateway over to the T1 router on the cloud side. And by essentially plugging those networks into that T1 gateway, they now become routable through the T1 gateway, right? So taking care of the network routing between the segments, probably first step in the plan. Again, kind of going back to, all right, customer's got to make the decision, execute the recovery plan, make a determination, which one of my sites is the most important, has the most critical workloads that I need to get up and running first, and execute the recovery plans for those workloads first, all right? The next thing that the customer would do once the networking stuff was kind of taken care of, right, is we worked with them to pre-create a number of NSX firewall rules, both for north-south traffic ingress, egress, as well as east-west traffic flow. Those rules were pre-created. Customers would simply need to go and enable those firewall rules on the various gateways within the VMware Cloud environment. Obviously, next point, AD FISMA roles, kind of move those over, get things up and running from an infrastructure services standpoint. And then after that, the customer would need to request, the required number of public IP addresses that they would need to be able to enable and configure T0 kind of NAT services to any services that they were going to be advertising, out to the internet. So an example of this would be their VDI environment, right? They would now need to advertise connection brokers out to the internet so that those remote workers, if there were any of them left, would be able to get in to access the applications that would now be running on the cloud side, right? Any public DNS records, update those to reflect the fact that now those applications are running out of the cloud. From a default route standpoint, VMware Cloud is actually pretty cool because if we're not advertising a default route to it, which they would have been doing from on-prem, the T0 router will just assume its own default route, which is its local internet gateway. So there will be no update required there. So north-south traffic would pretty much just happen as soon as BGP route propagation from on-prem broke when those sites went down. From a cluster standpoint, as workloads were being recovered, so the clusters would dynamically scale, right? And this is the beauty of VMware Cloud. Customer wouldn't have to worry about adding additional host capacity to these clusters as these workloads are being recovered, so additional capacity would be added dynamically. And then, of course, from kind of those outlier servers, Brian touched on it a little bit earlier. Customer leverage their own kind of capabilities and knowledge around those SQL servers, leveraging native SQL capabilities, SQL always on. So, one of the things they would probably prioritize is taking those replica database servers and making them read-write so that other workloads being brought online could start leveraging those databases. All right, we got like a minute and a half.
All right, so as we talked about, that covers the significant disaster recovery scenarios. So I'm going to touch really quickly on the ransomware recovery side of things, right? Let's say site A gets infected with ransomware. There's a whole workflow and process built into VLCR to help them recover. And there's obviously some considerations. I won't go into too much detail, but back to how they want to handle the layer 2 extensions, swinging the gateway. And all that really is to further isolate the networks, right? The affected workloads to make sure they're quarantined. We mentioned they're running production or test dev workloads up in the cloud, so really have an isolated T1 gateway, leverage NSX advanced firewalling, which is included to further isolate the networks and play around with that, what the workload has access to. Additionally, these VLCR recovery plans need to be built to have snapshots so they could go back to at a further point in time. And then really this VMC environment on AWS becomes like an isolated recovery environment, right? Or a sandbox or a clean room, if you will. Run some next-gen antivirus. It comes with features built in, or you can use your own. And really then the whole point is to triage the infected workloads in this environment in an isolated state. And then once you find that last known good point in time, restore those right back to on-prem without the risk of reinfection.
All right, so the final scenario that we architected for was that one that they threw a curveball at us. And that was just kind of partial site failure or individual application failure, right? And really by the nature of the design that we implemented, the fact that we had layer 2 stretch networks all over the place, really gave the customer the ability to define application-specific recovery plans so that in the event application failure on-prem, they just simply have to recover that application set into the cloud side. The app would be brought up still on the same network that it was on before, same whole thing, and they'd be good to go. So, and not impacting any of their current prod environment. So I think with that, we're going to wrap because we're at time. But hopefully this was insightful. Like I said, we have the full version of this talk that was recorded yesterday morning. Check it out in the videos. You guys will have access to those. And thank you very much. Any questions? We'll take them now.
How is the licensing on this site?
Yeah, so licensing is per protected virtual machine. So for live cyber recovery, you license per protected virtual machine, and then per terabyte of capacity for your snapshots that you're going to be storing up in the cloud. All right?
Okay.
Right now, today, it is VMware Cloud on AWS, but if you keep your ears and eyes open, you may hear something in the not too distant future about how this solution might be available for some other hyperscalers.
So in the event of a partial disaster, are you spinning up that snapshot in the DR side and replicating back in bot?
We would.
Or are they?
No, you'd essentially take the snapshot that you have on the cloud side, the most recent snapshot, so the good data set, and you'd bring the VM up